Next, let's take a look at how to create and delete parent constraints. First, let's talk about how to delete them. I've already created a parent constraint here. We can see it in the outliner. We might see some people delete them like this. They select the driven object, then select these blue attributes, then right-click, and there's an option here called break connection. We choose that. Effectively, this does break the parent-constraint relationship, because there are no longer any attributes connected to the driven object's translate and rotate. But we actually need to be careful here. This is a very unclean way of doing things. Why is that? It's because, as we can see here, our parent constraint node still exists. It wasn't actually deleted. It's just no longer connected to our driven object. If we keep doing this, when we start making more complex rigs, our scene will be filled with a lot of unnecessary nodes. So I hope we can all have a good habit when we're breaking this kind of parent-constraint relationship. Let's not just simply break the connection. What should we do instead? I've undone that. As we can see, the constraint is still here. What we should do is find our constraint node and then press delete to delete it. This is a much cleaner way to delete it. And finding this node is actually very easy. By default, it's always placed under the constraint object's hierarchy as one of its children. We just need to find our constraint object, find the corresponding constraint node in our outliner, and then delete it. Okay, next let's look at how to create one. We actually already covered creating it at the very beginning. We select our driver object, then select our driven object, and then under this constraint menu, we find the parent constraint. But this time, we need to look at its properties. First, a very important one is maintain offset. As we can see, my two objects are in different positions right now. So when I create it, they still maintain this positional relationship. But if I uncheck this box, now watch what happens when I click apply. We can see that our two objects have now snapped to the exact same position. This is the effect of not maintaining the offset. Another thing we need to note here is that this maintain offset doesn't use the values in our channel box as a reference. For example, we can see here our driver object is at -6 and the driven object is at 5. But if we freeze transformations on both of them, their own translate, rotate, and scale all become 0. But this snapping behavior still applies. So we need to remember this maintain offset is actually calculated relative to their pivot points. So for example, here, if I take the pivots for both and reset them to the world origin, I'm clicking on Reset Transformations in the Modify menu. Now look, when I create the parent constraint again, but this time without maintaining offset, it actually still keeps this positional relationship. Why? Because their pivot points are now identical, so there's no offset to begin with. That's something to keep in mind. The other important options are actually this translate and rotate. So here, if I uncheck translate, then in this case, when we connect it, we'll see that only rotation will affect it. Translation won't have any effect at all. We also looked at its attribute connections earlier. This is actually very simple. It just means the final calculated result from our parent constraint node is no longer being fed into the driven object's translate attribute. If we open our node editor here under Windows Node Editor and we take a quick look, we can see the constraint object only has its rotate connected to the node. And if we only turn on translate, then the effect will be the complete opposite. In this case, our translation will affect it. Rotation will still have an influence, but it won't affect its own rotation. This is still the same effect we're talking about. The driver object part itself hasn't changed at all. Its translate, rotate, scale, and its parent object's world position are still part of the calculation. It's just the final calculated result is only connected to translate. If here, the final calculated result, for example, we find our rotate and we connect it back again, then it just goes back to the original result we had. The only difference is we're just not letting it connect back to rotate anymore. So if we do that, it just means that in the end, the driven object's rotation simply isn't affected. So of course, we can actually do some more complex operations. For example, for translate, I only connect the x and z axis, and for rotate, I only connect the y axis. we can definitely do that. This is really the same as the behavior we just demonstrated. It all just means the result calculated inside the node is unchanged. It just depends on whether we finally connect it to the corresponding attribute on our driven object.